Seeking English S.A.T. Workbook, page 352, problem 3. Oh, this is a special problem. You're going to see what happens in the middle of this problem is something that is definitely going to happen to you on the real test. If you're ready for it, it's not a big deal. Oh, there it is. I was totally expecting it. Otherwise, this is a very dangerous problem in spite of how really simple it is. And I actually have already made a separate video specifically about this thing that happens in this problem, and it's worth mentioning repeatedly, so I'm going to try to mention the video again at the end of this video. In the meantime, 4r equals 24. What is the value? What is the value of 8r plus 3? Possible answers: 2, 3, 6, and 7. Now, just looking at the problem, the 8 doesn't really grab my attention, but the 3 and the 17 do grab my attention. And the 3 incidentally wrongly grabs my attention, but the 17 rightly grabs my attention. And so I'm going to show you what can go wrong in a problem that's this simple. Okay, so 4r equals 24. 24 becomes 6. Sorry, r becomes 6. Yes. 24 becomes 9. I'm not doing this again. Okay, r becomes 6. Okay, 6 times 8 is 48. That's 51. 51 over 17. Okay, now this is a part where you might think, no, I won't get stuck there. But people always say that, and then they get stuck there anyway. Students see the 51 over 17 and think, I have two prime numbers. That's not going to match any of these answers. You're wrong. It says, this problem says no calculator. So if you think you're stuck 51, oh no, just try it, please. Please just try to divide 51 manually by 17 and see what happens. Okay, good. Okay, 51 divided by 17 is 3. Why do they do this? Again, as I mentioned in the other video, and you can look for it and you'll find it on the same channel, 51 apparently is the number that students are most likely to confuse or mistake with a prime number, at least in proportion to its size. That is, the smaller a number is, the less confusing it is in terms of whether it's prime or not. The larger the number is, the more confusing it is, but the less likely it is to come up on a test. The sweet spot, or that is the most efficient way to confuse students about something being prime or not, seems to be to give them the number 51. And it's become kind of, for me, kind of a predictable cliche in math test design on all 3 math tests that I teach, which are S.A.T, GRE, and GMAT. So if you have 51 in your problem, you may see it at the beginning or at the end, and if you spot it, it's not there by coincidence. I have never seen 51 in a problem for any other reason. It is always there, as far as I've seen. It is always there for exactly the same reason. It's there to confuse you. In this case, you don't see it at the beginning. You don't see it at the end. So if you're not looking for it actively, when it pops up, you might forget momentarily if you haven't absorbed this point. 51 is the most dangerous number on standardized math tests. Absolutely. Okay, if you forget that 51 is not a prime number, even if you get the question correct eventually, you can lose enough time and enough mental energy that it can cost you another problem or several other problems. Okay, for this reason, I do recommend trying to memorize prime numbers between 2 and 53. That kind of assures that if you get to 53, you've gone past 51, and memorize that no, 51 is not a prime number. I don't want to stress this too much, because I do have a separate video about it where I show you a little bit more. But that's the key to this thing. That's why this problem, I hope you understand, that's the whole reason why this problem is in the book. Thank you.